Hello everyone. Now in this lecture we will know about the next concept, that means how determining whether the decomposition is lossless or the lossy. Now what exact the decomposition is? It is used to eliminate some of the problem of a bad design like anomalies or inconsistency or redundancy from the table. If we consider this one is simple a whole table, it contains 4 column A, B, C and D. Then we can say that the relation is A, B, C and D. And when we decompose this table, it may be run with the two relation R1 and R2. That is R1 is with A, B and R2 with the C and D. When we decompose this table into these two tables, then the information should not be lost. That one is in the particular main table contains A, B, C, D, then definitely the decomposition R1, R2 have all the information which one is available under the main table. And then why we decompose it? Because of we already know about the at the time of decomposition, or maybe why we normalize the table, because of the existing table have the anomalies, inconsistencies or the redundancy of data. Then we decompose it with the help of the normalization form. And then when we normalize it, when we decompose it, after the decomposition it should be maintained with the original information. It should not lost with the information of a column of a C. If we remove the C and mention the A here, then we can say that loss of information C, right? But this one is again the information is lost or not, that one is verified with some rule determining whether the decomposition is lossless or lossy with the help of these three conditions. The condition one says that if the particular decomposition done like R is divided into R1 and R2, then R1 union R2 is equal to R. If we go with this example A, B, C, D, then R contains A, B, C, D. R contains A, B, C, D. Then we can say that the first condition is true with the help of this example. That is the first condition. If we decompose it, then union of the newly prepared or made relations, that one is R1 union R2 is equal to R. That is the first condition. If it is not true, then we can say that the information is lost at the time of decomposition. Then if this condition is true, we will check the next condition, that one is R1 intersection R2 not null. R1 intersection R2 should not null, right? Should not null. Then we need to check the R1 and R2. If the R1 contains A and B, then R2 contains C and D, then we can say that the condition is false, because of these two not contains a common value, right? Intersection is a null, that's why this condition is false. We need to check this condition. If we got some common value, that is we can say that the R2 contain B, C, D, then the B is a common value, or it may be this condition is true now, and that one is a condition 2, which one is verifies the particular given decomposition is loss or lossless, lossy or lossless. Then if this condition is true, then we check the third condition, that one is again the R1 intersection R2, we got the B, then this value should be the super key of R1 or R2. If we got the common value from the newly created relation, then it as a third condition says that that value should be the super key of R1 or R2. That is simply the third condition. We will go with the simple example, and we can easily understood about this particular decomposition is lossless or lossy. Now this is simple. The example relation R, that one is A, B, C, D. Then it's have a functional dependency. That one is simply the A with a B, C with a D, and then decomposition with the R1 is AB and R2 is the CD, right? Then we will apply the condition 1, that one is intersection union of R1 and R2 is equal to R1 union R2 is equal to R. Is it condition true? Yes, because of union of R1 R2 is A B C D and R is also the A B C D. That's why this condition is true. Now we will go for the condition 2. Then condition 2, the intersection of the R1 and R2, intersection of the R1 and R2 is not a null. If we check with this example, AB intersection CD is not a null, but in this example it's showing a null value. That's why this condition, second condition, is false, and the particular decomposition is a lossy. We can say that this decomposition is a lossy decomposition. Okay, means with the help of this decomposition our information is lost. Then we will know about what exact the how exact the information is lost, because of the in this scenario A, B, C, D, all the column are available with the R1 and R2, but it lost the relation between these two tables, right? That's why this decomposition is a lossy decomposition as per the conditions. Now we will check the second problem, or it may be a second example, which one is true with the, or it may be not lossy. Now the R is A, B, C, D. Now it's have a functional dependency. Then we just divide this R into a R1, R2 and R3, means the decomposition of R into R1, R2 and R3. Now we will check the condition. Is the given decomposition is the lossy or lossless. Now this one is simply the R is divided into R dash and R3. That one is ABC as R dash, and then again ABC divided into the AB and the BC, and then at the end it come with the relation R1, R2 and R3. Now we will check one by one condition. That one is, if we check the R dash, first we just to apply the three condition with this two relation R dash and R3, R dash and R3, and then secondly we will check for the R1 and R2, right? Now the R3, ABC and BD. Now the condition 1 says that one is simply the union of R dash and R3 is a R. Is it correct? Union of ABC, BD, that one is true, right? Because of this two, union of this two is equal to this one. That's why the first condition is true. Now the second condition for this, that is the intersection of the R dash and R3, intersection of R dash and R3, common thing is B. then we can say that condition 2 is true, because of we got the b as a common value. It's not a intersection of r dash and the r3 is not null, right? That's why this condition is also true. Now condition 3, that is b should be a super key of the r dash or r3. B should be the super key. According to the condition 3, in intersection of both the sub relation must be the super key of one of the two sub relation or the both. Then now the closure of the attribute B is, we need to know about this concept, what exact the closure of the attribute. That is simply the B, that one is the super to check the particular value is super key or not. I will explain you in detail about how to identify the super key, how to identify the candidate key. In the next lecture, we will know about the condition 3, how we know about this B is a super key or not, right? Now if we go with the relation, that one is a given relation. If we check B, the closure of attributes means what? We have the given relation. This one is simple, the given relation. We'll check the closure of B with the help of B have a relation with C. B have itself a relation, that's why B is here. Then B have the relation with the C, then C comes under the as a closure attribute of a B. Then again C have the relation with the D, then again D is the closure attribute of a B. Now the D have the relation of B and B is also available. Then again all the closure is calculated. Closure of attribute B is BCD. This is the way to check the or get the closures of a particular attribute with the help of this functional dependency. If this condition is not available here, C is to the D, then the closure of attribute of B is the B and the C, not a D, because of this one is not available, considering as this one is the simple way to check the closure of the attribute. Okay, this is simply the condition. Now we see attribute B cannot be determined attribute A of a sub relation R dash, right? Thus it is not a super key of the sub relation R. Attribute B cannot determine all the attribute of a sub relation R3. Thus it is the super key of the sub relation R3. If we check it with the this relation, the BCD means the R3 have a B and D, means we can say that a closure of B is attribute B can determine all the attribute of a sub relation R3. This closure determines the B and D because of B and D is available under the closure of B. That's why we can say that it is a super key of the sub relation R3. But attribute B cannot determine attribute A of the sub relation R dash. If we check, A is not available under the closure of B. That's why we can say that it is thus it is not a super key of the sub relation R dash. Means the B is not a super key for this relation, but the B is a super key for this relation, because of it determines all the closure of the B, right, for the R3. This is simply the way to verify the super key is the given attribute, which one is intersection about the relation. If we got some value and that the value is the super key, yes, that one is a super key, which one is verified with the help of this way to find out the closure of that common value and then verifies the relations. Then third condition is also true, because of B is a super key of R3, right? That is simply the way. All the conditions are true, then we can say that this decomposition R2, R3 and R dash is lossless, is not a lossy, because of all the conditions are true, right? Now we need to verify the R1 and R2. with the same way. Now we will go for the R1 and R2. That one is simply the R1 is AB and R2 is a BC. Now R dash is a, that is the ABC. If we verify the R dash, that one is a ABC, and the R1 is AB, R2 is a BC. Now we first condition for this relation is true. First condition for this relation is true. Why? Because of the union of R1 and R2 is a R, right? AB, BC means ABC and ABC. Now we will go for the condition 2. That one is intersection of the R1 and R2 is not null. If we intersect the R1 and R2 is not null because of B is common. We can say that condition 2 is also true. Now the condition 3, that B, which one is, we know B, then third condition says that the value which one is find out in a condition 2, that one is the super key of the one of the relation, that one is R1, R2 or the both, right? Now we will again verify the particular B is a super key of the R1 or R2. Then we need to again find out the closure of B. That one is simply the B. Then with the given functional dependency, we will find out the closure of B, that is a BCD. Now attribute B cannot be determined the attribute A of a subrelation R1. That's why B is not a super key for the R1, but B is the super key for the R2. That's why again a third condition is true, right? Because of B is the super key of a R2. And again a second relation as a R dash is also true, and both the relation is not lossy relations or lossy decomposition, and at the end we can say that the given decomposition is not a lossy, is a lossless, right? Overall decomposition of a relation R is into a sub-relation R1, R2 and R3 is a lossless because of the all the condition for the both relation are the true. That is simply the way to identify the given decomposition is lossless or the lossy. Okay, it may be the exam contain this type of a question. It gives some relation and it's we need to verify or we need to find out the given relation is given decomposition is lossy or lossless. Okay, thank you.